Welcome to this class. Now, in this tutorial, I'm going to be introducing chemistry. This is introduction to chemistry. Now, our subtopics are definition of chemistry, branches of chemistry, then we have chemistry in our life, then we have what are chemicals. Then we look at uses of chemistry, we look at adverse effects of chemistry, then we have the careers in chemistry, or the career opportunities in chemistry. Let us begin with definition of chemistry. Now, chemistry is a branch of pure science that deals with the study of matter, its composition, its properties, its uses, and the changes that matter undergoes. Now, this is a simple way of defining chemistry. So, from this definition, we are able to derive that chemistry is under pure science. If you check our work on Introduction to Physics, we have defined science and we have said that science is divided into two major branches, that is the pure science and the social science. So the pure science is also known as natural science, and it contains subjects like physics, chemistry, and biology. So these three subjects are referred to the core science, and we can form an acronym with the three, which is Phy, Chem, Bio. So where Phy stands for physics, Chem stands for chemistry, and Bio stands for biology. Now, under the social science, we have subjects like civic, geography, economics, government, etc. So these are subjects or knowledge that have to do with human being in relation with his environment. They are not really the core science, unlike physics, chemistry, and biology, which are the major science subjects. So you can see that chemistry is one of them. There is no way you'll be a science student without learning chemistry because it's very, very important. It's very, very important. Now, in the definition above, we have the word matter. So that means chemistry is here to study matter. Matter is not a new concept to every science subject. From junior secondary school, we have defined matter as anything that has mass and occupy space. So from this definition, we can understand that almost everything in the whole world is matter. So far it has mass, which is also weight, even though there is a slight difference between mass and weight. So far the object or the substance can occupy space, then it is matter. For example, we have sand, stone, water, and other liquids. Even the air that we breathe in is a matter because it has mass and occupies space. Plants, animals, even human being is a matter. That is, even the teacher that is explaining chemistry now is a matter, and the students are also matter, and the whole people in the whole world are matter because we are all animals. An animal is a matter. In short, everything in the whole world is a matter. So because everything has mass and occupies space. Now, we can see that matter comprises both living and non-living things. So, because both living and non-living things can occupy space and they have mass. Also, from the definition above, we were able to talk about, we said that chemistry studies matter and its composition. So, each of these substances that we have here has some substances inside it. What are the composition of matter? We have atom, ion, and molecules. So, those are the particles of matter. So, it means no matter how big something is, it's still composing atom, molecules, and ions. In our subsequent video, we will explain more about atoms, molecules, and ions. This is just a brief overview of everything. So, and each of all of these substances that we call matter can undergo some different or series of change from one time to the other. So change is the only constant thing in the whole world. That's why chemistry must look into that changes. What is causing the change, and what do we even call that type of change that anything can undergo? Because when we mix one substance with another substance, some changes must occur, and that's what chemistry is here to talk about. Now, from this point, I should be able to talk about what we call chemical, because chemistry deals with chemical. What is chemical? A chemical is any form of matter, whether living or non-living. So far, such substance is composing of some matter particles like atom, molecules, and ion. Then that substance is a chemical. So chemical is any form of matter, whether natural or artificial. So whether it is natural or man-made. So far it contains those matter particles like atom, molecules, and ion. Now let's talk about branches of chemistry. Chemistry has three major branches, which are organic chemistry, inorganic chemistry, and physical chemistry. These three are the major branches of chemistry. So organic, inorganic, and physical chemistry. Now, in a simple way, if you are asked to define organic chemistry, according to the olden days definition, we say that organic chemistry is a branch of chemistry that studies non-living matters that are present in living matters. That is, those things that are non-living, but they are present in living matters, even though this definition is no longer acceptable in the modern days. Now, Inorganic chemistry deals with only non-living matter, even though this definition also is also not acceptable again in the modern world. Now, physical chemistry is a branch of chemistry that deals with the application of theories of physics to study chemical system. So, under the physical chemistry, this is where both physics and chemistry connect. This is where they both connect. So we have topics like enthalpy, entropy, that is chemical changes, like heat, energy changes, and so on. We have the radioactivity and many other ones, like the modern physics deals with. Now, what are the examples of the non-living matters that are present in living matter? So those examples are some of the food that we eat, like carbohydrates, protein, we have fats and oil, etc. We have many other ones in fruits, those acid, organic acid that we have in food, in fruits or plants that we have in our environment. Those are the kind of living matter, or sorry, non-living matters that are present in living matter that organic chemistry is talking about. But this definition is no longer accepted because most of these things can be prepared in the laboratory. We can practically prepare them in the laboratory. So that's why this is no longer acceptable. So now, what are now the non-living matter that inorganic chemistry deals with? These are the kind of substances that are not found in living matter. For example, so sulfuric acid, H2SO4, and so on, and we have hydrochloric acid and many other ones. Even though some of these ones too, many of these are prepared in the laboratory. Now, the acceptable definition of organic chemistry nowadays is that we define organic chemistry as the branch of chemistry that deals with the study of carbon and its compound, excluding its oxide, its carbonate, and its carbide. So that means organic chemistry studies every compound of carbon, excluding these three, that is oxides of carbon, then we have carbonates and carbide. Let's talk about oxides of carbon. Carbon generally has two oxides, that is carbon 2 oxide and carbon 4 oxide. Carbon 2 oxide is CO and carbon 4 oxide is CO2. Another name for carbon 2 oxide is carbon monoxide. Then another name for carbon 4 oxide is carbon dioxide. These two are not studied under organic chemistry, even though they contain carbon in them. So they are not studied under organic chemistry. So these are the oxides of carbon. Then what are carbonates? Carbonates are compounds that end with CO3. CO3 2 minus is a radical. So any compound that ends with CO3 2 minus is a carbonate. And this is another thing that organic chemistry does not deal with. Let me give you examples of such. We have H2CO3. H2CO3 is triisocarbonate 4 acid. Carbonate is CO3, which is triisocarbonate 4 ion. It's a radical. So H2CO3 is triisocarbonate 4 acid because of the presence of hydrogen in it. Another one is CaCO3. That's calcium triisocarbonate 4. And then K2CO3, this is potassium triisocarbonate 4, and other ones. All of these are not studied under organic chemistry. Moving on, what are carbide? Carbide are compounds that end with carbon. So a carbide is any binary compound that has carbon as the second element. So binary compound is any compound that is made up of two elements. So, and the second element is always carbon. So it always ends with carbon. So it can be metallic. The first element can be metal or semi-metal, which is a metalloid. So that's why examples are, we have the calcium carbide, CaC2. We have silicon carbide. The silicon carbide is also known as tungsten carbide. Now we have the iron carbide, which is Fe3C, which is also called cementite. Now, all of these and more and others, which are carbide, are also not studied under organic chemistry. So excluding these three, which are oxides of carbon, carbonates, and the carbide. So these are the only three things that contain carbon that organic chemistry does not study. But every other compound that contains carbon is studied by organic chemistry. So what are now the type of carbon compound that organic chemistry studies? Let's see some examples. So these are the examples of carbon compounds studied by organic chemistry. So we have glucose, C6H12O6, methane, CH4, benzene, C6H6, carbohydrate, CX H2O Y. So we have many other ones. So we have the general formula for each. We have the hydrocarbons, we have the pure hydrocarbon and impure hydrocarbon, and so on. Now, by now, we have defined chemistry. I can mark that. Then we have also done the branches of chemistry. So we can now move to chemistry in our life. Now, many things that we do on a daily basis, we are applying some chemistry principle which we don't know. Look at some of the things that happen in our environment and some of the things that we personally do For instance, burning of firewood is a chemical process. Then cooking is a chemical process. Drug making, chemical process. Lighting of match is a chemical process. Production of palm wine, roasting of nails, rotting leaves, and so on. Those are chemical process. Look at some chemical reaction that happen in our everyday life too. Soap and detergent too. It's a chemical process. Hair cream and perfume, oil and margarine, plastic made from chemical processes. All of these are chemical processes that we apply in our daily life, and we might not even be aware of it. So for a layman now, they don't know anything about all this. They don't know that they're applying chemistry in their everyday life. Also, previously, I have treated chemicals. I have defined what are chemicals, so I don't need to go there again. Now, uses of chemistry. Though we have looked at some of it under chemistry in our life, but we can still consider some of it right now. Now, if we consider this part of the notes, we will see that chemistry has a lot of uses in our everyday life, and it contributes to a lot of things. Without chemistry, life will become primitive, and we may not be able to do things easily and more conveniently. So, for example, in food, chemistry contributes to it. Chemistry contributes to clothing, then military, so like the production of guns and weapons. Then in space, so chemistry makes it easy for space travelers, those that travel in rockets and planes and so on. Then housing, chemistry helps in the production of cement and other building materials. We have medicine, chemistry contributes to pharmacy a lot, and production of vaccines and drugs. Then we have transportation. Chemistry also contributes to transportation in the sense that it produces some fuel, the fuel that we use to move our cars and fly our planes and so on. These are some of the uses of chemistry in our everyday life. Now we need to talk about the adverse effects of chemistry, some adverse effects of chemistry. Let's look at some of them. Now, what do we mean by adverse effect of chemistry? That is some of the disadvantages of chemistry, some of the negative things that are caused by chemistry that are harmful to life of human being and other living things. So now, the first one is pollution. Pollution is one of the adverse effects due to some smokes or some odor, some bad odor coming from industry, chemical industry. So this is one of the ways that chemistry is having some adverse effect. Then drug abuse. So because chemistry produces some drug that are harmful to human, and then some use drug without doctor's prescription, and some of the drugs that chemistry produce are intoxicants. They make the youth go crazy. So many of that. And then corrosion too. Corrosion is also one of it because iron rust is the meaning of corrosion. Because of some chemical process that happen every day, you will see that some gates are rusting, some iron materials are rusting. So this is one of the adverse effects of chemistry. And another one that I need to add now is production of ballistics and weapons. Production of weapons. So all of these are also being abused by those that are meant to be using them, like guns and some ballistics and weapons like cutlass and so on. Some people are possessing those harmful instruments and they are not licensed to have them. Now, in this last chapter, we look at some of the careers that are linked to chemistry. So, and then the job opportunity that we can have under chemistry. Now, if you study this part, you will see the careers that are linked to chemistry and then the job opportunities. These are some of the careers that are linked to chemistry, like agriculturist, chemical engineer, medical doctor, and so on. Then, under the job opportunity, somebody can work in the teaching sector, a chemist can work in industrial sector. The knowledge of chemistry can make you even become an entrepreneur, etc. Thank you for viewing this. God bless you.